Saya Ainaa binti Majmul Rahman, and I would like to talk about introduction. The ideal gas law experiment will measure the pressure and volume of a gas sample in a syringe to determine the number of mole present using the equation PV equal nRT. By examining how pressure, volume, and temperature relate under different conditions, we can evaluate how closely the approximate ideal behavior.
What is an ideal gas law? Ideal gas law is a mathematical definition of the relationship between a number of significant gas parameters based on a condensed model of the behavior of gas particles. Because of this, gas calculations and forecasts can be benefit greatly from it. We can make some easy predictions. One particle in the gas moves in random motion and the identity of the gas is irrelevant. And also, the particles don't interact apart from elastic conditions, bouncing off one another like balls on a pool table. When examining an ideal gas, we want to be able to discuss 4 variables. One is pressure, where it defines how often they hit the sites. Number 2 is mole, where we should find how many particles are there in the gas. Third is volume, how big is the container, and the last one is temperature, defines. Let's look at the piston while keeping the moles and temperature the same. In the other words, the same number of particles moving at the same speed. If we compress the volume, the pressure must go up. The particles will be hitting the sides more often because there is less distance to travel to hit a site. That means that pressure and volume are inversely proportional if one goes down when the other goes up. So let's move on to the example calculation of ideal gas law in refrigerator. For example, a refrigerant contains 0.5 mole of ideal refrigerant gas at 2 atmospheric pressure, 0.02 cubic meter volume, 300 Kelvin temperature. Using the ideal gas law, we can rearrange the formula to gas constant is equals to pressure times with volume per number of moles times temperature. Plugging in the given data, we can determine the gas constant, which is 0.00222 for this ideal refrigerant gas.
Moving to the next slide will be vacuum cleaner. Using a hand-operated vacuum pump, we can demonstrate the relationship between pressure and volume of a gas. According to gas law, the pressure of a gas of constant mass and temperature will be inversely proportional to its volume. A vacuum cleaner Campbell 5 liter 300 kg lowers air pressure from 1 atm to 0.5 atm. Using the ideal gas law, PV equals to nRT, the number of moles of air removed can be calculated as 0.5 times 5 liter divided by 0.0821 equals to 0.025 moles. So about 0.025 moles of air are removed from the 5 liter vacuum clamber when reducing the pressure from 1 atm to 0.5 atm at 300 kg.
Next, for the hair dryer. The hair dryer with volume 0.002 cubic meter operate at 100 Celsius, 373 Kelvin. Using the ideal gas law, PV equal nRT. The pressure inside containing 0.01 mole of air is 0.01 mole of air at 373 Kelvin in the 0.002 cubic meter hair dryer volume gas pot where internal pressure of about 154,530 PA as calculated using the ideal gas law.
A steam turbine is a machine that exerts terminal energy from pressurized steam and uses it to do a mechanical work on a rotating output shafts. Here's a shortened version. Steam enters a turbine at 500 degrees Celsius, 10 bar pressure and 2 meter cube volume. Using the ideal law, gas PV equals to nRT. So with the given temperature, pressure and volume condition, the steam contains 311.2 moles as calculated by the ideal gas law.
お買い上げありがとうございます。